Hey everyone, Kevin here from Focus Astronomy, and welcome to another episode of Starstream. And if this is your first time actually joining us, Starstream is a virtual, interactive digital star party that takes place right here online. All the images that you're going to be seeing tonight are actually streamed live off of our telescope, which is just outside the control room right here. Um, and so everything you're going to be seeing is live. There's no editing on this. It's straight off the telescope and into the digital world for everyone to see. And this is basically allowing us to travel light years without ever leaving home. Of course, we're actually not going that far tonight. We're actually going to be sticking on the moon tonight. So this is the first time we've ever actually done a dedicated lunar star stream, and hopefully it'll be the first of many. Actually, just to show you kind of what we're working with, the image in the background, this image in the background here, this was taken off of our C11, and that's an 11-inch telescope. But for all of my telescope people here, tonight we've actually upgraded. Tonight we're actually using our, at least new to us, Celestron C14. This is a 14-inch Schmidt-Cassegrain telescope, and we're using a point gray Grasshopper 3.0, which has an IMX 250 CMOS sensor in it. This is a monochrome black and white camera, and the reason that I prefer to use monochrome for my events is because they are way more sensitive than a color camera is. So I like pulling out the details and the structures and all of that. So for all of our techie equipment people, this is the rig we are running tonight. We are running at full 14 inches of aperture and 3,905 millimeters of focal length. So if you're a photographer, imagine using an 800 millimeter telephoto lens and timesing that by 5. This is what this telescope is doing. So we are going to be looking at the moon tonight with this system, and we are zoomed right in there, and we've got all kinds of stuff to actually check out. So it's going to be pretty neat. But if you're into gear, this is the setup that we are using tonight. So that'll at least give you an idea. So again, this is the Celestron C14 Schmidt-Cassegrain 14-inch point gray Grasshopper 3.0 camera. This is on our Paramount MX mount, which keeps everything nice and pointed in the right direction and tracking. And then for our motor focusing and making sure everything looks sharp, we're using the Starzona Micro Touch Focuser. So that is our rig tonight. So we're gonna give it a go. So tonight, of course, we are gonna be observing our next door neighbor, the moon, and this was actually shot about 10 minutes ago. This is using a Canon EOS R in a 100 to 400 telephoto, handheld 400 millimeter. So you actually don't need a telescope to get a nice image of the moon. You can actually go out with just a small camera and a decent lens and capture a nice image of the moon. So this is what we're looking at right now. You go outside right now, this is what we're looking at. And the moon has phases depending on where it currently sits in its orbit around Earth. So tonight we're just about first quarter, which means this is all lit up in daylight. And then of course we have the nighttime side in there as well. Nicole, why do I have a diagonal? It was there, so it just made things easier to focus. So usually you'd go straight through the telescope, but it was already there and it works. So we're going through the diagonal tonight. So this is what the moon looks like tonight. We are in first quarter. And this is just a picture I went out and shot about 10 minutes ago with a Canon 100 to 400 millimeter lens, just so we get an idea of everything. This actually allows us to see more of the dark regions on the moon that are visible tonight that we're going to be working with, and these are called mare. which is actually the Latin word for seas. So these are all quote-unquote seas. There's no water in them. There's no atmosphere up there, so it all would evaporate in no time. So all these dark regions on there are known as mare, and all the higher areas, the white areas, those are called the highlands. So we're going to be kind of bouncing around the moon tonight, checking out different craters and different geological regions. But this is what we'll be working with tonight on the moon, at least. And just so we're all acquainted with what regions we're looking at right now. So right down here, this is one of the smaller seas. This is called the Sea of Nectar, like the flower nectar. Just above that, right over here, up on the edge here, this is the Sea of Fertility. Just over here, I like this one the most. I just think it looks cool sitting out on the edge there. This is the Sea of Crises. And then probably the most famous one is this large section right here. This is Sea of Tranquility, with Apollo 11 landing site. And we're actually going to try to hunt that down here shortly. Just above that, this large lobe up here, this is Sea of Serenity. Just below that, we have the Sea of Vapors. And there's only a small section visible tonight, but as it gets closer to full, you'll see more of this. This is the Sea of Showers, or Sea of Rains. And we're going to spend some time right on this ridge line tonight, really zooming in on that right there. And just up top here is the Sea of Cold. So these are the mare that are visible this evening, and there's a bunch of other ones, probably at least another 4 or 5, maybe even 6 that are in the night area at the moment. But these are all the different types of, or all the different mare that are visible this evening. And then we'll actually be playing around in there. We're going to be checking out some of the craters down here in the southern pole. And actually getting a closer look, a lot closer look than 400 millimeter focal length. But if you have any questions or comments throughout the webcast, you can go ahead and write in on the chat there. I'll be happy to answer what I can. And we'll have fun tonight and just kind of play around on the moon. And then, of course, let me get past this. Here we go. If you like what we do here, you can go visit us at focusastro.org. Hopefully when the world returns to normal, we'll be able to do our outreach events again in person, so you can take a look through the telescopes. If you like the virtual star parties, you can subscribe to the channel, and that way you know when we're going to do another one. We normally do these every other Friday. Tonight we're doing the moon. And in 2 weeks, weather permitting, as well as a ton of other personal life stuff, hopefully we'll be doing some intro into the summer skies, digging into some of the nebulas and stuff when there's no moon in the sky. But as we move into June and July, into the summer months here, we're going to start dealing with monsoons. So hopefully, as things progress further, we'll be able to do these, but things might become a little bit more hit and miss as things move forward. So, but tonight we are all on the moon. So I'm gonna switch off our PowerPoint here and let you guys take a look at what we are on. So actually, we're drifting a little bit. Zoom over here. Whoop. Other way. So we're kind of chasing some clouds tonight. So this haze that you see in there is probably going to be some high haze. There's supposed to be some clouds moving in a little later tonight. So we'll see what we can do on that. But so this is the moon. This is at full resolution on the telescope that we're using tonight. Let's go full screen. And I don't want to capture anything right now. Ugh. Let's get this out of the way. All right, so a little bit out of focus actually. So let's fix that real quick. First time doing the moon on this whole thing, so there is going to be some learning experiences here. So bear with me. There we go. I'm going to kind of get this a little bit more focused. So the one problem with telescopes like this is they hold a lot of heat. It was also 109 degrees outside today, and the telescope just sat outside all day. So there's a lot of heat built up in this tube right now. This telescope actually does have cooling fans on board, which is nice, so that's going to help. But there's still a ton of heat to deal with, and it looks like some clouds are kind of invading our stream here. So we're going to do the best we can tonight. And the nice thing about using a camera is with the clouds getting in the way, we can just increase the exposure a bit. But they will affect how sharp everything's going to look tonight. So we'll fight with it and make it look the best that we can. So let's get started here. Okay. All right, so we are looking at the moon. This is the full focal length of this telescope. So this is what 3,000, about 3,900 millimeters of focal length looks like. And it's quite a lot. So this is really allows us to kind of get in there and really get a sharp look at a lot of this stuff. So as long as the clouds don't invade it too much. So right now we are on one of the, kind of on, what side are we on? This should be the eastern limb, is what we're kind of hanging out on right now. And I'm just trying to find the craters that we're currently sitting on. And then we can get started in here. So let's move the telescope to a section real quick. There we go. Perfect. Okay. All right, let's kind of cruise around the moon here. Looking for, let me slow this down a little bit so we don't fly off the moon. Again, this is a live image of the moon. As you can see, we are way up in there. I'd love to figure out how close this would look in reality, like what this would equate to if you were in orbit, like how far away this is going to look. So one of these days I will figure that section out. So right now, let me center this up real quick, and we're just gonna center up right there. Okay, so we are on our first mare or sea, is where we're actually at right now, and the clouds are kind of messing with the exposures. See if I can dim this down. Whoop, too bright. There we go. All right, so we are on this particular sea right here, like what we talked about earlier. This is the Sea of Crises, which is up on the northern portion, just above the equator of the moon. This particular sea is about 3.8 billion years old. And these low-lying regions, these mare, you'll notice actually don't have a ton of craters in comparison to the highlands. And the reason being is these mare are actually low-lying regions on the moon. And long ago, this was actually filled in by material when the moon was early on and still kind of in its molten phase. A lot of these dark regions, these dark plains, are basaltic. So they're high in magnesium and iron, and they rapidly cooled down when they were younger. So they have these dark regions. So these have not been cratered nearly as much as the highlands have. So this is how we know that they're actually younger than the highland areas, because there's not as much crater damage or impacts sitting on the mare area as there is on the highland area. So that's how we know that they are actually younger in age. But we're still talking, particularly right here for the Sea of Crises, we're still talking about 3.8 to 3.9 billion years old. So if you're into vintage, yeah, this is it. Looks like the clouds kind of stopped messing with us, so I'm going to try to sharpen this up a little bit until they come back. So, but yeah, so this is the Sea of Crises right here is what we're looking at. And this is about 375 miles by 345 miles in size. So it actually covers a good section of the moon is what you're seeing here. So again, this is the Sea of Crises, kind of in the northern section of the moon, northeast section of the moon. So it can easily be seen naked eye or in a pair of binoculars or in a telescope. You don't need anything near this big to enjoy it, but it does allow us to get down in there pretty easily. So again, this is the Sea of Crises is what we're on at the moment. I'm just going to leave the controls up here because it'll allow us to drive around the moon a little bit more. We're going to move on from the Sea of Crises real quick. Here we go. So let's continue on with our lunar tour. Now, just next door to the Sea of Crises, I can get the telescope mount to point where I want it to. Right up here. Whoops. There we go. Right above the Sea of Crises is probably the most famous and well-known sea. And let's center that up right here. This particular region right here, this is... There we go. This is the Sea of Tranquility, which many of us are obviously familiar with the Sea of Tranquility, because this is where Tranquility Base or Apollo 11 actually landed on the moon in 1969. So this is the Sea of Tranquility. Let me bring up the camera here just so the clouds don't constantly mess with us. There we go. So this is Sea of Tranquility. Now, the Sea of Tranquility is a pretty large piece of real estate on the moon. It's fairly circular, but we're talking about 424 miles by about 424 miles, roughly. This particular region sits between 3.9 and 4.5 billion years old. And it looks like the clouds are coming in, and hopefully they're not going to be too bad. Let me go check outside, just see how bad we're looking at real quick. All right. It looks like we're going to be battling clouds a little bit tonight. Hopefully we'll get through the whole thing. There's not a ton of them out there quite yet, but it's not going to be the perfect skies like we were hoping for this evening. So we'll see what we can do with it and get the best out of it. So this is the Sea of Tranquility right here. Apollo 11 landed right here, and we're going to try to see where Apollo 11 actually sat. And let me get my controls up here, pop that up there. So we want to find Apollo 11's landing site roughly. Now, this particular telescope obviously does not have the resolution to resolve the actual landing site down to a perfect location, but I don't have the budget for that. So one day you can go up and take a look at it online. I'll try to pull them up here in a second, actually. See if I can get the Lunar Reconnaissance Orbiter images of this one. But while we're doing that, let's see if we can track down roughly the region of that. So now the moon is actually a lot of fun. I've actually just kind of started to appreciate it more. As someone who does a lot of deep sky observing, we're always kind of cursing the moon and wishing it wasn't around, but it's actually a pretty neat location to take a look at when you have the chance. And a lot of us kind of curse it because it takes away from our nice dark skies, but it really is kind of a world within a world for us to check out. So let me cruise us over right over where Tranquility Base would technically be. All right, so let me pull up my little chart here. So Tranquility Base is right in this region, and what we're basically looking at are a set of craters that we want to try and catch. And this is just like star hopping, actually. So if you ever want to pull up a map and kind of cruise around to find different regions of the moon, this is the place to do it. It's really kind of I've gotten to have a more appreciation for the moon by simply going out and viewing it more. So the first set of craters we want to look for is this chain of craters right here. These large two are the ones we're looking at the most. This upper one, this is called Rainier. Now the Rainier crater is about 19 miles in diameter and about 3,900 feet in depth. And that is the first crater that we want to find. And then just below that is the crater Sabine. And I'm probably going to butcher some of these names, so if you're a lunar fanatic, I'm sorry, but I'm trying my best on some of these names. But this crater right here, this is the crater Sabine. And Sabine is just a little bit smaller. This is 18 miles in diameter. So just giving you an idea of what kind of resolution we're actually working with tonight. And this telescope can normally do a lot better. It's just with these clouds kind of coming in, it's messing with stuff. So I'm going to take us down in resolution and kind of pop us in here a little bit more. There we go. So drag this in here. There we go. So this is the crater Rainier right here, and this is the crater Sabine. And as we start looking in here, this is roughly where Tranquility Base is currently situated. Actually, will always be situated for our lifetimes. Hopefully, we'll see. So hopefully we'll get to the moon sooner rather than later. But moving over from that set of craters, you start to move further down to this crater called Moltke? We'll call it Moltke. I probably butchered that name too. But this crater right here, this is Moltke. And Moltke right here is one of the larger craters that is near Tranquility Base on the moon. And Moltke is 4 miles wide and about 0.8 miles depth. And it is 31 miles from the Apollo 11 landing site. And so the Apollo 11 landing site is actually right about here is where we are looking. Now, what's kind of cool here, and I'm trying to see if the telescope can resolve this. Clouds are being a bit of a pain. Flip the other way. There we go. It's gonna be hard to catch it, but if the seeing was better, we would be able to catch these. I don't think we're gonna have the resolution. There are 3 craters in this region right here. This is one of them right here. This small crater, this is Collins. And this one is Armstrong. So we have Armstrong, Collins, and then Aldrin is actually over in this region. But I don't think the seeing is going to support that this evening, unfortunately, just because we're fighting a ton of clouds. There you go. So this is Armstrong right there. This is Collins. And then Apollo 11 would sit right about here. Now, just to give you an idea of the resolution that we're talking about right now with these craters is, let me get my little charts up here. The moon is literally a world within a world. It's really a microcosm, if you will. So you could, like star charts, you could be there forever. The moon's the same way. The more power you put on it, the more craters that you actually see. So right here, which we can barely make out because of the wind outside with the clouds and everything, this particular crater, which is Aldrin, or I'm sorry, this is Armstrong, this is 3 miles. So right now we're able to just resolve a 3-mile crater, and this is 240,000 miles away from the Earth. And then right over about here, we have the next crater over, which is Collins. And Collins is even smaller. This is 2 miles in diameter. So our max right now is the ability to resolve down to 2 miles with this telescope currently. So we're seeing objects that are only 2 miles wide from 240,000 miles away from the Earth. So that's pretty cool. And that's even through some garbage seeing that's outside right now. So right here, this is the crater Moltke, and then this is the crater Collins, and right in between there in the middle is the Apollo 11 landing site. And if you go online, and let's see if I can pull this up real quick. If you go online to the Lunar Reconnaissance Orbiter website, you can they actually have pictures of the lunar landing sites now. Pull this over here. This is what happens when you have really nice set of cameras. This is the Apollo 11 landing site from orbit using the Lunar Reconnaissance Orbiter, and they have photographed all the landing sites. You can even see some of the footprint areas and all the places that they were walking around on the moon. So there you go. We did it. We landed on the moon. There's a picture of it. You're welcome. So there's that. So you can see the seeing's getting a little bit better, a little bit. There's Collins right there and Armstrong, and I can't quite make out Aldrin over here, but we're kind of drifting a little bit too. The wind's kind of kicking at us. That's a big scope outside, so it's having to fight any little breeze that we can out there. So let me try to center this up. Right here. Right in there, that is where Apollo 11 is. So that's our first set of objects to see tonight. That is the Apollo 11 landing site, 240,000 miles away from the Earth, and that is where man first set foot on the moon, right here. So pretty neat. And this is in the Sea of Tranquility. All right, so let's get our camera back to full resolution and zoom back out. Oop. And let's see if we can adjust this real quick. There we go. While we're here, we have a large crater just out of the field here, and I'm going to adjust this really quick and bring that in so we can see that. There we go. Other way. Get used to the controls. All right, this crater right here in the center. This particular crater is right on the edge of the Sea of Tranquility. And this particular one is known as Theophilus. Theophilus is 61 miles in diameter. So 61 miles edge to edge of that crater. It's about 13,300 feet deep. And this does have a central peak, which is actually pretty cool. Some of the larger craters have that center peak in there. So it's a pretty interesting crater. And that center peak right there is about 45, almost 4,600 feet tall. So about 0.8 miles tall. And this appears to be about 2 billion years old, roughly, is how old this impact crater is. So this is on the Sea of Tranquility right there. It actually sits between Sea of Tranquility, which is up here, and then the Sea of Nectar, which is down here. So that is the Sea of Tranquility, Sea of Nectar, and then Theophilus crater right there in the center. And then you actually have this little crater up here, which is Theophilus B, and that's only 5 miles in diameter, but it sits on the outer ring of that large crater right there. So it's pretty neat to actually see some of that. So, all right. So let's continue on our tour of the moon here. Next time we might set up a wide field telescope as well, so we can actually see the whole moon at the same time, but you can only control so many things at once. So we're going to make our dive down out to another set of craters in the in another mare right next door. And that is, oh, clouds are coming in again. They were not supposed to be here until later, so we're kind of fighting with the clouds, as we always do. If you don't like clouds, don't get into astronomy, because obviously they affect everything. So let's see how long I can hold on to this. It was supposed to be clear until about 10, so this is all coming in a lot earlier than expected, but you know, we'll hang in there and see what we can do with it. So I appreciate you guys all coming along for the ride, and you know, we'll just see what we can get out of it. So but the nice thing is we can always up the exposure on the cameras, and it can kind of help us cut through the muck until the clouds get even thicker. So but let's keep perusing the moon and get to our next spot over here. Okay. Get situated here. On our next set of craters. Keep moving over. Moving for our next target. We need to head to the northern part of the moon for our next position on this tour. And let's get the telescope up in that position. So moving up. There's our crater set that we're looking for. Actually, So where the shadow crosses the sun, or where the shadow crosses the face of the moon, which would basically be sunrise, this is known as the Terminator. So you can see some of these long shadows that are coming out of the craters. It makes it look real dramatic. This is actually sunrise in those craters right now. So this is actually where we are going to be situating ourselves next. So we have two craters right here, two large craters. The first one right here, this is Aristillus, I'm sorry. 33 miles wide, about 11,100 feet deep is how deep this crater is. And then it has its neighborhood companion right next door, just below it. This is Autolycus. These are all named, many of these are named after old Greek astronomers. Aristillus right here, like I said, 35 miles in diameter, about 2.2 miles deep. It does have a center peak, but the shadows or the sunlight has not hit that center peak yet. Probably later in the night is when that'll start to hit sunrise there. This is named after the Greek astronomer Aristillus. Now, just below it, like I said earlier, this is Autolycus. This is a 24-mile wide crater, 2.1 miles deep, and this is named after yet another Greek astronomer. So why are we in this region? Well, we're actually looking at yet another Apollo landing site right here. I'm going to try to center this up real quick. And I'm not sure I can get this any more focused, but let's try. That looks a little bit better. When the seeing actually likes to cooperate here, we're kind of having to deal with all of that at the moment. So what we're actually seeing here is, and then we have this other large crater that's actually just coming out of the sunlight, or into the sunlight. This is Archimedes. You can see sunlight on the crater rim right there. And Archimedes is a much larger crater, 50 miles in diameter, 6,500 feet deep. So it's over a mile. It's about 3.8 billion years old. So this is the crater Archimedes. Now, these three right here kind of form a triangle within this ridge line that we see over here. And if I can get the telescope to move over just a tad, other way. This ridge line right here, moving in over here. Let me adjust the camera down a little bit. Go. So this is where we're actually looking right. So this is Aristillus, this is Archimedes, and you have Autolycus right here. So these three right here, and then you have this opening in the ridgeline right here. Now this is an actual ridgeline is a bad term for this. This is a mountain range right here on the moon. Yes, the moon does have mountain ranges, and this particular mountain range is Montes Apenius. Again, I probably butchered that. A lot of this is Latin. So this is a mountain range right here. It's actually named after a mountain range in Italy. This is about 3.9 billion years old. But we're actually looking for a specific region on the moon right in this region. And let's see if we can pull it out and catch what we're looking for here. Because we're on our next Apollo landing site, essentially, is what we're looking for. So, right here, and let me see if I can pull up my little square. Boop. And shrink this down so you guys can check where I'm actually talking about. Right there, right in the center of that square. You can kind of see it. If we let's see if I can go to a higher magnification real quick. Flip this in. There we go. Drag this over here. Not quite. A little bit up. Over. All right, right in the center Let's see if I can get... Yeah, so right in the center of our box there, I think it looks like a happy face. You have an eye there, you have an eye there, and you have this smiley face looking thing here. That's actually a rill sitting in the moon itself. So what that actually is, it's almost like a river. There's no water in it at the moment, obviously, because there's no water up there. But this is called Rima Hadley. It looks like a river system right there. And just within that region is Mount Hadley, which is the brighter region just to the north of that, right over here. That's Mount Hadley, which is actually 14,000 feet in elevation. So you have these two little mountains over across from there. Bring up the camera a little bit. Two little mountains right there. If you look close, there's a little rill, almost looks like a smiley face or a little river sitting in there. There is a tiny crater called Hadley C. Hadley C is about 3.7 miles in diameter. And just across the way there, right in this region, is where Apollo 15 landed. So this is the Apollo 15 landing site region, right in the center there. My little square is kind of falling around. There we go. Right in the center of that square, roughly, is the Apollo 15 landing site, right not far from Mount Hadley, in this region right here. If the seeing was a little bit more stable, see if I can calm this down a little bit. Speed the camera up. All kinds of stuff we can do with this conflabit technology. And let's see if I can get us a little bit more focused. We are fighting with some clouds and wind that was supposed to come in tonight, so it decided to come in earlier than expected. So I was hoping things would be a little more calm. It's also fairly hot outside, so we're working on that. But we're actually looking in this region right here in the middle of that square. That is Apollo 15 landing site, just off of the little rill right there in the center. It looks like a smiley face, and Mount Hadley. So this is the Apollo 11 landing site, which is actually right in the middle of one of the larger mare. Not quite in there, kind of drifting off in a minute. Let's pull the telescope back over real quick. We're getting hit by some breeze outside that's kind of messing around with a lot of what we're trying to do tonight. We have a little system coming in that was not expected so early, but such is life. But right here, right in the center there, that is the Apollo 11 landing site, and 240,000 miles away, and right in here. So pretty cool to see. So we did the Apollo 11 landing site, we did Apollo 15, and the large craters that surround them. Like I said earlier, if you're just joining us, this is Aristillus right here, followed by the lower crater Autolycus above here, and then the large crater just above, just coming out of the shade there, is Archimedes up there on the edge. And I can actually go to, we'll actually catch that right here. We'll go to full screen. There we go. There's Archimedes up there. So kind of cool set of craters right there. And of course, this is on the one of the seas up there on the moon. Let me double check where we're actually at. It's hard to navigate when you're zoomed in this much, but this is actually the Sea of Showers is what this is right here. Just a small section of it. Most of it's still in darkness at the moment. So let's continue on our tour. If there's something you'd like me to get that I haven't gotten, you can let me know. Just, feel free to shout it out in the comments if there's something that you want me to check out. But we're going to continue on cruising the moon up close and personal. So let's continue on with our tour. what's cool about the moon is when the seeing conditions are actually good, when you look close, there's all kinds of these little rills and canyons and all kinds of stuff that you can actually catch in the moon. So, just if you're a deep sky observer like myself, or you prefer galaxies and stuff, that's great. But don't forget about the moon. The moon's kind of a world within itself, and I know a lot of astronomers, including myself, kind of overlook it. But spending some time on it is not a bad way to go, and it's never affected by light pollution. So no matter where you live, you can always enjoy looking up at the moon, regardless of how bad the seeing conditions are or wherever you live. Light pollution is not part of the equation at this point. So even the smallest telescope is a great little lens to catch all kinds of details on the moon. You don't need a big telescope like what we're using tonight to see. This obviously is helpful in certain aspects, but even a small set of optics, binoculars, or even your naked eye, it's a lot of fun to go check it out. But it does look like a big old golf ball, doesn't it? So we're going to continue on to our next region of interest, and we're kind of sticking along the Apollo sites tonight just because they have all kinds of stuff to check out on that. So let's see if we can find the next Apollo landing site for us at this point. So let me find our next position, and we will get on that really quick. Now, there are thousands and thousands of craters on the moon, so there's all kinds of things that you can actually observe when you're looking on the moon. So it never stops, and what you can actually check out up there. So it's really kind of pretty neat. So let's see if we can find this next site while the clouds are still holding themselves off real quick. Get in position here. But it's actually pretty neat. You can spend hours and hours and hours checking out the moon. It can never, at times, never gets old. While we're here real quick, I'm pretty sure this should be the crater Proclus right here. And Proclus is about 17 miles in diameter, 7,300 feet deep. And it sits right there on that mare that we hit. Or this is Sea of Tranquility over here, and of course we have that other mare, which is the Sea of Crises, right next door. So Sea of Tranquility, Sea of Crises, and then this pretty cool crater that kind of separates the two in between. That should be the crater Proclus, is what that crater is, and you can see these are called rays. The rays are basically dust that's kind of shot off the crater and then landed back down. Kind of when you hit a golf ball into a sand trap and some of that sand goes flying. That's what we're seeing there. So this one's about 1 billion years old. So little older than your standard sand trap. So, but something cool to see. Something different. Large craters are pretty cool, and as the moon approaches more towards full, you will start to see more and more details start to come out. So it is pretty neat to see what you can get on it, and it doesn't take a lot to actually enjoy the moon. What we're running with right now is way overkill for the moon. So, but it's a lot of fun to share that with everybody tonight. But the wind is getting kind of obnoxious, that's for sure. Let's see if we can find our next landing site in this jiggly image here. Okay. There was one thing I was hoping to show you guys, but it's not going to happen until tomorrow, and that's the straight wall. The straight wall is this really cool ridge line that actually is lit up only in a certain part of the moon phase, and that's tomorrow night, I believe. So if you have a chance to get out tomorrow, go online, look up the straight wall. It's actually a pretty cool feature to check out if you have a chance to definitely check it out. So okay, let me get situated. Trying to navigate across the lunar surface when everything's zoomed in takes a little bit of time, so we need to head down south, further down, right about there, and then we have to head over into the lit side of the moon. There is no dark side of the moon. Unfortunately, Pink Floyd did not have that accurate. There is a far side of the moon. Both sides of the moon get equal amounts of light. So you basically still have the nighttime side and you have the daylight side. So no dark side, I'm sorry. But, you know, that's just how things work. So now I think we've actually zoomed in on our next target site. Let me get situated here. Make sure we are actually on the same spot. Not sure we are at this point. So lots and lots of craters up on the moon, thousands of craters, and you could stay busy for weeks observing the moon. So but trying to navigate when you're this zoomed in can be challenging, even with a detailed chart. So okay, there's those three. We already did this one earlier. This is Theophilus, which is a monster crater. Then you have Ceruleus right down here. And you can see that Ceruleus was actually older because Theophilus actually overlaps it, which means this impact occurred before this one actually occurred. So that's how you can actually tell what's older and what's not. So kind of a neat thing. So these three right here actually point us to the particular crater that we're looking at, which is this guy over here. I'm going to move the scope that way real quick. There we go. So right in the center here, let me double check. I think I've got my little square on. Let me turn the square off. We don't need that anymore. I'll just use the pointer tonight. So you're going to see this particular crater right here. And you're going to notice that it has a little crater inside it. So this is called Descartes. And you have Descartes and Descartes A, which is the little crater right here. The little crater actually came after the main impact. So Descartes A right here is about 9 miles in diameter. So just to give you an idea of the resolution that we're getting right now, that's 9 miles. And then it's part of a larger crater system right here, and that's about 29 miles in diameter. So an even bigger crater system at that point. Now, not far, let's see, clouds are killing us tonight. Constantly having to play with the camera. So this is the crater that we were talking about. And then right above that is another set of craters that we're going to try to pull out. Clouds are coming and going. Constantly having to change. If I put this on auto. That's too dark. So okay, so we have this crater here. Then right above this crater, or these craters right across from this main area right here, we have two other craters. This is called Lindsay and Doland B. So the Lindsay crater, which is right up here, kind of looks like a figure 8. Let me bring this down real quickly. Oh, other way. Next time we will pull the diagonal out of the telescope, make it a lot easier to navigate so you're not playing mirror image constantly. There we go. That's better. Let me get situated. So we're looking right in this region right here. So this is Doland right here. This is the crater Lindsay. The Lindsay crater is named after an Irish astronomer, Eric Lindsay. It's 20 miles in diameter, 1 mile deep. And then its next door neighbor, which is Doland B, technically, is 23 miles in diameter. And then as we kind of move our way down, and so we're right in this particular section right here. And right in this particular area is Apollo 16 landing site. Right in there, right in that center there. So we find this crater right here at the little crater. Find these two smooth craters. And they kind of just point us in that direction. So actually right down here, I'm sorry. Right in this region is the Apollo 16 landing site. And there's a little crater right here at the tip of the arrow. That's Doland T, which is 1.8 miles in diameter. So we're resolving almost to 1.8, almost to a mile resolution at this point. So that is the Apollo 16 landing site right in there, just off of the craters Lindsay and Doland B. So Lindsay, Doland B craters take you right across there, and little crater right there, that's Doland T. T is in Tom. And right in this section is the Apollo 16 landing site. So pretty neat. Something different to see that crosses 3 of the Apollo landing sites that we actually got to this evening. So we did Apollo 11, Apollo 15, as well as Apollo 16, which we are currently on right now. So pretty neat stuff. Let me get the camera to zoom. Whoops. There we go. Let's see if I can pull this in a little bit more. Speed up. So right in this region, right here. Scoot this over a bit. That's better. I did this earlier. So here's Lindsay, here's Doland B, and then right in this region in here is actually where we're actually looking at for Apollo 16. So pretty neat. This is the Apollo 16 landing site is what we're looking at this time. So if you're wanting to hunt these down, you can get a detailed star chart. There's actually a cool atlas you can download for free online if you really want to learn more about the moon. It's called Virtual Moon Atlas. You can download that and click on all the craters. It tells you all kinds of specs about it. So it's actually pretty neat if you want to get into the moon. It's been very, very helpful for learning the moon and being able to kind of check things out on a much more detailed scale. So those are the 3 Apollo landing sites that we're actually going to be checking out this evening. So we're going to just check out a couple more craters and then we'll wrap it up for the evening. And it's amazing how fast an hour goes by at this point. But crazy. So let's get the controls back up on the telescope. And let's try to head further down south into the southern pole of the moon. Actually, we're going the other way. Everything's mirror image. You got to remember that when you're using these a reflecting style telescope. So it does look like we're in orbit around the moon. So let's we can cruise along the Terminator here real quick. That's where the shadow crosses and we can actually slow this down maybe a little bit more so and kind of take it in. Just looking at the scope does an actually really nice job on the moon. Long focal length and large aperture is really what you want for shooting planets on the moon. So it's actually kind of neat if you've got like a Schmidt Cassegrain, like an 8-inch Cassegrain. Those definitely work really well for the moon. And just real basic set of cameras will do quite well on that as well. So, but nothing super fancy here other than, there we go, up the ante there. Back on our controls. Just kind of cruise the moon. This was back at the Apollo 11, or this is the Apollo 15 landing site right down here. Seeing's getting a little bit better. I'm not sure if the clouds are kind of dissipating or maybe the winds are dissipating, but it seems like things are calming down. The scope's also cooling down, which is really, really important. When you're doing the moon, if you're magnifying a lot, you're actually magnifying all the heat and the garbage that's up there as well, so it's not good. But you can actually see all these little ridge lines and all these what look kind of like rivers all down through there. Those are pretty cool to see, especially when things are looking good. This particular thing we're looking at right here, where'd it go? This region right here, let me bring it down. Other way. Right here in the center, this kind of fissure looking thing right here. This is actually pretty cool. And this is called Huygens. This is kind of it's a craterlet system, but it actually has a ridge or kind of a fissure that kind of crosses in through there. So that's about 6 miles wide, this little craterlet right here. And then the fissure kind of extends out many miles outside of that crater system. And this is something that you can see in about a 4-inch refractor. If you've got more aperture to back you up on that, then that's always helpful as well. But 4-inch refractor should be able to grab this kind of detail in there without much hassle at all. Now we're going to continue down to the southern portion of the moon as we continue. And there are, like I said, there are thousands and thousands of craters. So if you ever want to explore the moon, I highly recommend just taking the time to do that, because it's actually pretty neat to see. You can see all kinds of stuff that's starting to come out of the darker regions, and that of course is called the that's called the Terminator. So it's definitely something that's kind of cool, ever changing, for you to check out as well. Let me get on the charts right here so we can get back to naming some craters. So these craters right here, I think actually look kind of like a snowman. So this is Ptolemy right here, and this is about 4.5 billion years old. This is almost as old as Earth itself. This is a large crater, about 93 miles in diameter. And then right next to that, just below that, with this crater right here, what is cool here is you can actually see the shadow cast from that center section right there. That peak right there is getting all the sunlight. You can actually see all the shadows, and even back over here in this crater. But this is Alphanus. Let's see. Yeah, Alphanus. I'm probably butchering these names, so forgive me. That's the crater just below there. This one's a little smaller. This is 71 miles in diameter. It does have that central peak there, which is also pretty cool. And you can see that nice shadow. Almost looks like a clock. Clock arm going from there. And then just below that, to wrap up the three, you have Archel right down here, which has some pretty good detail and a nice central peak in there. This is only 59 miles in diameter, but it's 10,900 feet deep. So it's pretty deep. This is about 3.8 billion years old for this particular crater. Let me back down the exposures a bit. Oh, other way. There we go. So zoomed in pretty well there. Let's actually go to full frame. There we go. Back it off a little bit. We could actually go all the way in if we really want to get crazy. And see if we can speed this up a little bit. So playing with the camera settings, you're able to capture a lot of different things and grab that scene while it's really, really good. It's kind of a technique that you would actually use for planetary imaging. So rather than sitting there and, let me blow this up actually. See if we can get this a little bigger. There we go. Kind of mushy, but this is all heat in the atmosphere actually. This is just scintillating heat in the telescope and the atmosphere. So if it's windy or anything, and this is why we actually do, you want a high-speed camera for planetary imaging, because what you're seeing is, you can almost see where the seeing calms down and things are really sharp. You want to grab that when you can. So these little cameras that shoot really quickly, they shoot a video and they're shooting thousands of frames, and what they're doing is they're grabbing little sections of that image there, and they're actually able to oh, we have an ISS pass. Let's see if we can catch it. We tried this last time. I'm not sure where it's at right now, but we are more than well equipped right now to catch a space station flyby at the moment. So let me go to... Bear with me just a second. I was not prepared to have a space station flyby tonight. And I think it's really low in the north and the east. So yeah, we're going to be too low tonight to catch it. Maybe. Yeah, what the heck, let's try it. Let me zoom out here real quick. So, there we go. Okay, sorry about that. Let's see. I tried this last time with no success. But let's see if we can find it. Hopefully I don't pull anything out of the telescope. Ooh, this is going to be really low. I don't think we're going to get this one. Okay. Where's the cameras? See. We are really low right now, so I don't think we're going to be able to... Nope, we're in a tree. That's why we're not seeing anything. Hopefully sometime soon we will be able to get the space station in one of these. It is not in a good position right now, and I didn't expect to get it tonight. But hopefully we'll be able to get that sometime soon. So The mount actually is tracking it right now, but it is really, really low to this right now. So, yep, we already lost it because it's in a bad part of the sky. As you can see right here, it is really low on the northern horizon. So we weren't quite able to get that tonight. We're super low. So we weren't going to be able to catch that tonight. That's not a good part of the sky for where we're observing in anyway. So let's see if we can get the telescope back on the moon and get back to what we were doing. But it was worth a shot. So let's send the telescope back over to the moon, and hopefully in the future there we can catch it once again. So it was definitely worth a shot. So we'll plan accordingly next time. But the telescope that we're using tonight and the camera combo, if we were actually able to get the space station in there, you would clearly see solar panels on it. That particular combo that's out on the scope right now would easily do the space station in really incredible detail, but it requires everything to be in just the right spot. So, all right, well, we've only got a couple minutes left. If there's nothing, let me get this all kind of pop back into position there, since we had an unprecedented setup there. If there's anything you guys want to see, obviously we did the Apollo 11 site, we did Apollo 15, we took a look at Mare, a lot of different things on the moon, and it's actually gone by rather quickly. So if there's anything you want to see, definitely let me know. Or if I miss something, you can definitely just write in the comments there if there's something you want to see. I'd be happy to check it out. Let me try this one more time. I'm gonna rush this real quick and see if I can get the telescope. Yeah, we're not gonna do it tonight. It's gonna be still too low. So hopefully on another night we'll be able to get it. If you're in Arizona, I think it's June 4th to the 6th, somewhere in there. You'd have to check it. I think there's a really good ISS pass if you're in the Arizona region. If not, you can go to heavens-above.com and put in your location and see what you can actually get for yourself in your location. But definitely give it a try if you want to check that out. So jump back on the telescope here and just kind of peruse some of the craters. If there's anything that you'd want to see tonight, definitely let me know. I'd be happy to send the telescope over to that particular region. It would have been nice to get Venus. Venus is very, very close to the sun right now. It's getting ready to make its transition from the evening star to the morning star, and we actually shot that in this telescope the other night, and see if I can find it just to show you guys what you can actually glimpse on it. But you want to be really, really careful with Venus right now because it's only like 7 degrees away from the sun, so it is toasty. So you want to be careful with all of that if you have a chance to catch it. But it's definitely worth seeing if you can catch it. It's very, very low in the western sky. It's still naked eye visible in the western sky, but there's only a couple nights left that you can actually grab it. So if you have a chance, definitely try to get a glimpse of that. Or it's going to move into the evening sky. The morning sky here in the next probably week or so. But Venus you can catch. Mercury is out in the western sky right now, if you want to give that a go. And then, of course, we'll have the moon in the nighttime sky. And then as we are later in the evening, or if you're an early riser, you can get Saturn, you can get Jupiter, and you can get Mars. So all of that is up in the nighttime in the evening sky. So all very cool stuff for you to see out there. So the planets are coming. Maybe in the fall we'll actually do something on the planets, or we'll do like a mixed night where we'll get to see some pretty cool stuff. But the moon's pretty cool. Here is the image of Venus from the other evening. This was shot through the telescope that we're actually using right now. This is the planet Venus. Real thin crescent right now. Venus has phases just like the moon does, which is pretty cool. But you can see this razor thin crescent Venus actually out in the evening sky just before, just after the sun goes down. So just be careful because it is really close to the sun. But something to check out. Let's see, what's the trench? This area right here, that would be, let's actually double check what we're looking at the moment. Kind of in a weird spot in the moon, which is kind of down. We're on the northern portion of the moon actually, so everything's mirror flipped because we are actually using a mirror based telescope, so everything is inverted. So I will have to check on that one, Alex. I'm not sure which this region is right here, but we are on the northern portion of the moon at the moment, not far from the actual top. It might be a little further up. I'll have to take a look into that one. I'm not sure. So that's really all I've got set up for you guys this evening. I know it's a little shorter than the last couple ones. Of course, if you want to join us in 2 weeks, weather permitting, definitely we hope to have you around. But this has been kind of a cool introduction to doing lunar live streams, and we'll see how that works in the future, whether we continue to do them on their own or we just kind of split them with another virtual star party. But it's kind of neat to just peruse that big golf ball in the night sky. So definitely get out, get a moon map. If you're stuck at home like the rest of us, get the family outside and go explore the moon. Any size telescope works just fine for this. Bigger telescopes can even be interesting too. So if you've got a big old telescope sitting in the garage, sometimes popping it out and looking at the moon can be pretty cool. But it's a fun thing to share with friends and family as well. So this is the moon. If you've enjoyed this webcast and you want to see more, you can go ahead and subscribe to these Focus Astronomy YouTube channel. It just lets you know when we're going to be doing more of these in the future and if we do any other kind of special videos. But right now, that pretty much wraps up our virtual star party of the moon. And definitely hope you enjoyed it. And if there is anything you'd like to see in the future, definitely you can write to us at focusastronomy@gmail.com, or just go to our website. And hopefully one day we can all be together actually looking through telescopes again. But for now, we'll be doing these virtual star parties. So in 2 weeks, weather permitting and life permitting, we'll be back doing deep sky and checking out some cool distant objects in the summer skies. So you can actually go to our website, focusastro.org, and check out all the upcoming events and see what actually is of interest to you. And we definitely hope to see you sometime in the near future. So thank you very much for watching. I hope you have a great weekend. And definitely stay safe out there. And thank you for watching. Take care, guys.